Hello, am I audible? So, in the last class, we had talked about the different types of um, reactions where we have different type of reactions. We have discussed about that. So today we'll be talking about this one. So, need to check the annotation here. Today we are going to talk about determinacy and indeterminacy. Right? So we'll be talking about this determinacy and indeterminacy today. So what is basically this one determinacy? So what we'll do? So the structure in which all the member forces and support reactions cannot be found out. These are using any kind of equations of static equilibrium. They are known as your indeterminate structure. Okay. So, what is indeterminacy? What do you mean by this indeterminacy? Indeterminacy is nothing but here the structure in which all the members from, that means inner members, suppose all the forces and the support reactions which cannot are not found in they cannot be found out, okay, by using the equation of static equilibrium. Like equation of static equilibrium was what? Summation. How I can write now? I am not able to write this one because equation of equilibrium was what? Summation of x equal to 0, summation of y, all in all the directions you have to find out the uh, forces. Summation of x is equal to 0, y is equal to 0. These three equations are there also for moment if there exists any moment. So summation of moments also in all the directions we have to do. Okay, so basically if your support, above we will be talking about this indeterminacy. Okay, because if I talk about before that, if I talk about your determinacy, so in the determinacy, what will happen? Roller support, ring support, all the reactions. Um, Internal stability. Okay, process. We are not going to do process. We'll be doing for this one, determinacy and indeterminacies. Okay, because generally we'll be trying to find out the indeterminacy. We'll be trying to find out these indeterminacy. Okay, so what is your externally indeterminate structures? Suppose your support structure, if your support reactions can be calculated by using equation of static equilibrium. Equilibrium structure is said to be. Okay, the support reactions cannot be calculated by using this one. If your support reactions can be calculated, okay, by using equation of static equilibrium, and you know the equations of static equilibrium, there are we'll have to find out whatever reactions that are based on that, the summation of x, y, in all the for 2 dimensions and 3 dimensions, we have to find out the moments also in fixed support. Okay, so the structure is said to be externally determinate if your support reactions can be calculated by using these equations. Using these equations, if you can find out the support reaction, that means they are externally determinate. Otherwise, they are externally indeterminate. Another thing, suppose if by knowing all the support reaction, we can find out all the number of equation of equilibrium. Okay. Otherwise, what happens if by knowing all the support reactions, we can find out all the member forces using equation of equilibrium, the structure is said to be internally determinate. Okay. Otherwise, internally indeterminate. Okay. So, what is your this one? If I show you this one, externally determinate structures and your internally determinate structures. Okay, so what are they? Your externally determinate structures. Your externally determinate structures, if the support reactions can be calculated by using the equations of static equilibrium, the structure is said to be externally determinate, otherwise it is externally indeterminate. Okay, if by using all the support reactions we can find out the member forces, like how much forces are coming with the help of these reactions, then the equation of by using this equation of equilibrium, then the structure is said to be what? Internally determinate, otherwise internally they are indeterminate structures. Okay, that means understood now. Like if determinate means what? If we can find out the support reactions, okay, by the use of the static equilibrium, then the structure is said to be determinate, otherwise indeterminate. And if your support reactions, we can use those for finding out the member forces. Okay, using this equilibrium of set equation of static equilibrium, the structure is here internally determinate, otherwise internally indeterminate. So if we talk now about your this one, degree of static. Degree of static indeterminacy. What is your degree of static indeterminacy? Degree of static indeterminacy, you can make it to be d suffix s, ds also, like how much degree, how much it is indeterminate. Calculate by using inverse applications. So degree of static indeterminacy means what? That is denoted by ds. Is what? Degree of static indeterminacy is your number of extra equations required apart from the equations of static equilibrium in order to analyze the structure. These additional equations are called compatibility equations. Like, I'll see how you can find out the degree of static indeterminacy. Degree of static indeterminacy is the number of extra apart from the These additional equations are called what, they are called to be compatible equation. Okay, so what is your degree of static indeterminacy? That means your degree of static indeterminacy is the number of extra equations. Like for normally we take how many? This is the x direction equation, the summation of all the forces in the x direction. Okay, so this is the x direction, summation of all the x direction forces, summation of all the forces in the y direction, summation of all the forces in the z direction. So basically these three are your different in different direction the forces. So what is the degree of static indeterminacy? That is the number of extra equations which is your required apart from these static equilibriums, summation of x, y, z, in order to analyze the any kind of structure, whether it be a beam, okay, any kind of structure. So these additional equations are called to be compatibility equation. Your additional equations are what? Suppose this is your ds, that is equal to what? ds is your degree of static indeterminacy. So your ds is your nothing but d SC plus your d SI. What is your here ds? ds is nothing. DAC is what? This DAC. DAC is the degree of the external static indeterminacy. Then you have your this part. So your actually your degree of this indeterminacy is a summation of your degree of external static indeterminacy and the internal static indeterminacy. So if I mention you here this what, these are your degree of internal static indeterminacy. Okay. So this is very important. Okay, so degree of basically now what is your DAC? This is the total number of support reactions. Now what is your DAC? This DAC. So that is your DAC is equal to your total number of support reactions minus number of equilibrium equations. Okay, so your basically your DAC, which is this, is what? Total number of support reactions minus your number of equilibrium equations. Okay, so that is what, suppose this is equal to your the number of reactions is your R and minus number of equilibrium reactions, that is 3, because we know this is summation of x, summation of y, summation of z. So number of equilibrium equations is 3. So DAC is equal to total number of support reactions, which is R, minus this equilibrium equation. Equilibrium equations is 3. So 3. Okay. For this is for basically 2 degree. 2D. For 2D, this is that. But again, if you want for 3D, for 3D you will have different, which is R minus 6. So if you get R minus 6, that is equal to how much? R minus 6, this is for your 3D. This is for your 3D, you have your total degree of external static equilibrium is how much? R minus 6. So this you have to keep in your mind. This DAC, what is your DAC? Your DAC is nothing but this one. Your DAC is the total number of support reactions minus your number of equilibrium equations, which is R minus 3 for your 2D. r minus 6 for your 3D. Okay. Now, static indeterminacy. Suppose let us find out. Okay. This is generally always is equal to 0. Okay. Let's do this part. So we have this DSI is generally your this DSI, this one is 0 equal to 0 because DSI is generally east. For east we are having this one. Okay, fine. So that means what? You are having your degree of static indeterminacy is DSC plus DSI, where DSC is your degree of external static indeterminacy, you have your degree of internal static indeterminacy, then that is what this DSC is your nothing but support reaction minus your equilibrium equations. Deepu Rajvamshi 035. You're saying something?
Itu balik disun, jinci. Balik disun. Kali akan kau disini gisi. Falan deh. Tinggi dia berada dekat. Kelas berapa?
Hello. Can you mute your mic? Hello.
Apa teman lagi ya begini?
Hello. Okay, so we have this part. So in this internal one is how much? This is 0 for our beams. Okay, so now let us take a problem sum on this. How to find out your this degree of static indeterminacy. So we'll take a question. It's a simple one. Okay, so a simple one we'll take now. So if we take I'll draw one line here. This is the question. This is the question. So this is your question. Find out your DIS. That means your DS. This is your beam given to you, which is fixed from this side, and this is hinged. So a pin jointed, that means. So now you find out what is the degree of static indeterminacy. How you will find out? Can you find out yourself? Hello? Hello? Am I audible? Hello?
Yes, ma'am.
Okay, so we were about to find out what the degree of static indeterminacy, right? For this particular beam, when you have, suppose this is a member, here you have the fixed, it is fixed here, it is hinged here this side. So find out the degree of static indeterminacy, how much. Just now we had, I have given you the formula for that, how to find out this ds. If anybody gets the answer, please inform. Anyone? Just now I have given you the formula for finding out this DS. Huh? Okay, what happened? Anyone? Let me check the participants. Damtiri, Difu, Kaka, Devika, Remo, not there. Okay, so how you can find out with this? What was your formula? Your formula was, suppose now the solution, if I say you, oh, solution will be what? Hello, am I connected? Am I audible? Because I think my connection was lost for a moment. We are having problem. Hello, am I audible? Hello. Currently using the network. Yeah. Hello, am I audible? I think I got disconnected. Hello, now I'm audible? I think this recording is not
Yes.
working properly. Hello. Kimanu. Aseto connected. Hello, am I audible?
Yes, ma'am.
If I am audible, then we can go and solve the problem now. But one or two questions we'll take regarding that topic. Hello, all are sleeping over.
Yes, ma'am.
Yes, ma'am. You're sleeping. I'm asking you, you're sleeping or what? Now you're telling yes, ma'am.
No, no, we are not.
Okay, okay. I'm sharing my screen. No, আছে but এই কাম নকৰে. And I don't want to now, but then yeah. So I was showing you this. I gave you one question that was this fixed one. This is a fixed 2D beam. This one, this, 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 this. This is fixed. We have this is hinged. This portion is hinged. Okay. So this was your question. That find the area of certain intelligence. Okay. So now, what was our solution? Solution was our DS. I had discussed right before this that what was our DS, the degree of study indeterminacy is given by how much? That is your ESC, that is the external one, plus your the internal. Okay, static indeterminacy. So as I. So now to find out these DS, that means what? The degree of static indeterminacy. If you have to find out, you have to find out this external plus internal. So remember this thing that for any kind of, this is a 2D beam, so for any kind of beam, for all types of beams you will have your this internal indeterminacy is always equal to 0. So here suppose I can write here. And what is your DSC? I told you what was your DSC. Your DSC was how much? The reactions minus your the equilibrium number of support reactions minus number of the equilibrium. Yeah, I'll just write it in. Number of reactions minus number of equilibrium equation. Okay, so that is how much. This one is equal to how much? Number of reactions minus number of equilibrium equations. Equilibrium number of, that means this R minus your 3. This number of equilibrium equation is summation of x, y, and z, that is 3. So R minus 3. So what is the R? R is the reactions here. In the previous class, in the previous class we have discussed that how we get the reaction, support reactions. What are the support reactions when you have hinge support, when you have your fixed support, when you have your um, hinge you have, or you have any fixed support or simply support. Okay, so what are your reactions we have discussed? So find out how much is for this particular beam where this side is fixed and this side you have pin jointed. Okay, simply supported, hinge support. So R minus 3, that is the reaction for this plus this, you will get your total R. Here this is 0. Internal is always 0 because of any kind of beam when you have, this is always equal to 0. Okay. DSI, that means this one is always equal to 0 for any kind of beams. So DSC is how much? DSC is your this one. R is how much? Here this R. How many reactions will be there? So if I show you, these are your reactions. You see, for this fixed one, how many reactions you have? The movement is restricted for from all the sides, that means x direction, y directions, as well as for the movement also is restricted because since it is fixed here. So how many reactions you will have? You will have, this is one reaction, this is one reaction, and you are having this one reaction. Okay, so these three are there for you. So if we number this one is 1, this is 2, and this is your 3. Okay, so 3 are there for the fixed, and for this how much, how many are there here? Restriction is from the top, that means the vertical in the y direction it is restricted, so only this will be there, this one, this. Okay, so here since this is hinge, so this is restriction, movement is restricted from the vertical side, it means no vertical movement, also no horizontal movement. So that means what? One reaction support from this side, horizontal reaction support from this side. 1, 2, 3. This is 4. This is 5. 1, 2, 3, 4, 5. So here, but here movement is not restricted. So you will have how much? You will have here total reactions. How many reactions you have got? 1, 2, 3, 4, 5. Right? So you will have, so obviously now you got your reaction this side, 5 minus 3, how much? So you will get your reaction, that is 2. 5 minus 3, 2. That means what is your DAC? Your DAC is 2 plus 0. DAC is 2. So DAC is your 2. Equal to 2. Okay, so this is your answer. This one is your answer. So degree of, for this you will be given one beam like this, like it may be fixed from both side or it may be hinged from one side fixed, one both side hinge. So you have to calculate the reaction and then you have to find out the degree of static indeterminacy. So here for degree of static indeterminacy is how much for this particular beam? 2D beam, we have the degree of static indeterminacy is 2 degree. So in this way, you have to calculate the degree of static indeterminacies for different types of structures. Now I'll give you another question. You try now and find out the degree of static indeterminacy and give me the answer. Okay. So I'll give you one question. Now the question is, you have, this is a beam here. You have this one here, support. Okay. So from both sides it is fixed. Okay, so this is your question. Question 2. Find out and tell me the answer for DS. What is your DS? Easy. Tell the answer.
3, ma'am. Answer is 3. Is it right? Or
Hello?
3, ma'am.
Yeah, correct. So you have how many here? How many reactions were there? There were, these were your reactions. 1, 2, 3. And this side also 3. Same. So DSI is 0, DAC is how much? R minus R is 6. Let me show this side one. Now, see the 3 6. So you will have 6 minus your 3. This is one thing. Plus 0. So DS will be how much? Equal to 3. Okay, so this was your simple kind of 2D beams where you have to find out the reactions and you have to find out the degree of static indeterminacy. Now, if I give you one different question, try this if you can. I am going to erase these things. Okay. So our next question, if we do, we have this is your figure. Okay. Then this is at the center. Okay. The okay, these two are fixed from here. This is your P. This is P. You have here this. This two from both the ends it is fixed. Okay? It is fixed from both the ends. Now you find out the degree of static indeterminacy. Find out the degree of static indeterminacy. Take it as an assignment. Okay, this one as an assignment. Or in the next class, I'll be asking you like what was the DS for this. So you take it. I'll now I'm the class, so I'll give you the link. Wait, I'll share you the link for your attendance now. Take this as your classwork, you can say. In the next class, you have to give me the answer for this. What is your DS, the static indeterminacy for this? Sorry. Then you have this loading here. Okay. This is your link. I'm sending you the link here. You can go to this link and then give your attendance. Okay.